Global change has the potential to affect many aspects of the organization and functioning of marine ecosystems. For instance, if we think in terms of warming, the increase of temperature in the ocean has been more or less 0.7 degrees during the last century, and that can affect the distribution of species. And we are already seeing that species that are more adapted to cool climates tend to see their ranges of distribution more constrained, more reduced towards northern latitudes or higher latitudes in general, whereas species that are adapted to warm temperatures tend to expand their ranges of distribution. The warming of the ocean, the increase in temperature, not only affects the distribution of the organisms, but it can also affect their phenology. Phenology is basically the timing of the life cycle of organisms. For instance, the moment in the year when we observe the highest abundance of an organism can change in response to climate change and in particular to warming. And some species tend to see their peaks in abundance advanced, moved forward in time, whereas other species tend to see their peaks in abundance delayed. The response of each species is individual, and that means that the linkage between different species and the trophic relationships inside the ecosystem can be altered by warming and climate change. The warming of the ocean can have important impacts on the primary production, the CO2 fixation activity by phytoplankton. And this effect can be different in different regions. In tropical and subtropical regions, the main problem phytoplankton face is that there is a lot of irradiance, there is a lot of light, but very little nutrients. As a consequence of ocean warming, primary production and the activity of phytoplankton will be reduced. The situation is completely different in high latitude systems, in high latitude regions, such as the Arctic, for instance. There, the main problem phytoplankton face is the lack of light, because the mixing of the water column is very intense. Now, if the water column becomes more stratified in the polar regions, that actually means that phytoplankton are likely to receive more light and therefore to increase their primary production. So the same warming trend can have opposite effects on phytoplankton productivity in different regions of the ocean.